Today we're going to tackle the Caesar cipher as part of CS50. Alright, let's head to the code.
You're a phony!
Alright, so we're doing the Caesar cipher. And here is just describing to us what we're going to be doing, the basic way the Caesar cipher works. Just you're shifting whatever letter you're focusing on by the key that you're given. So this looks pretty cryptic. I pretty much just came up with something on my own. This probably works better than what I did. I basically just went in and did it in the dumbest way possible, but it works. So I'm going to show you how, but first we're going to go to the pseudocode. I'm going to enlarge it a little bit. Alright, so here we go. The main problems we're going to face are getting a key from the user and encrypting a word. And breaking this down further, we have to get a key from the user, store that key, validate the key, take the string input from the user, store the string, validate the string from the user, handle the case where the key is small enough to just tack on, and handle the case where the key is larger than the alphabet, so we have to wrap around. And then actually encrypting the word and printing it out to the screen. To face these includes, these are the libraries we're going to need. Oh, it didn't pull in the CS50.h. So like I said, quick and dirty, but it works. We're going to start with the main int argc argv. You know it's dirty whenever you start off with the main. There's no functions involved. So start off with the if statement. We're going to check if argc is equal to 2. And if it's not equal to 2, we're going to print an error message. Okay? We have to check if it's 2 because we need 2 arguments for this to all work. And if the user isn't giving us 2 arguments, then we might as well just, give them the error message and not waste our time running the rest of the program. So this error message is going to be usage Caesar key and then new line. This is just what CS50 tells us that they want to see. They also want to see us return a value of 1. Return 1. Okay. Next, we're going to be doing an else if statement to catch the cases that we do have 2 arguments. And if that's the case, we can move into this statement. So the purpose of this whole section would probably benefit from being a function, but it checks our key for validity, aka if it's a number. But first, we convert index 1 of argv to an int. A to I is the function we'll be using, and it's a part of standard library.h, and it returns an integer from a string. So the way we're going to start this off is we're going to make a constant int key. I'm using a constant because I'm not expecting the key to change. So a to I argv1. So as you can see here, we're taking the index of 1 of argv. We're not taking 0 because 0 would be Caesar, and the 1 is the actual number that they're putting in after the Caesar. So then we're going to store a Boolean to use as an off switch, like if we detect a bad input. So the reason we do this will become clear as we keep going here. So we're going to have a key called isKeyValid, and we're going to set it as true. So we're just going to assume that the key is true for now, but we're going to check it in just a bit. So to check it, we're going to have to store the length of our key. We're going to do that with an integer string. We're going to use the function stringLength from the string.h library, and we're going to take the length of argv1. So it's going to return a number and give it to len. So now we're going to loop that checks each digit to see if it's a number. So for int I equals 0, we're going to start at 0, I less than len. So as long as I is less than the length, not equal to length, once it becomes equal to length, we break out of this loop. And then what are we going to be doing in each iteration, checking each number? So let's say the user gives us a key of 24. That's 2 digits. So we're going to check 2 and we're going to check 4 because it's actually a string right now. So a string is just an array of those numbers. So the 0 index is going to be 2 in that situation, and the 1 index is going to be 4. 2, 4, becoming 24. So we have to do if, and we're going to pull a function from another library. We're going to be doing this a lot. If is digit, which is part of ctype.h, detects a non-digit, it'll set our stored Boolean to false, and it'll end the loop because we don't need to keep going at that point. So we're going to actually call this digit here. We're going to feed is digit argv1, but of argv1 we're going to take I, and if it is false, as in is digit returns false, we'll set our isKeyValid to false as well. And in plain English, you can just see that the key here is set to false. So that would mean that we would have to start over and ask for the input again. But I want to get back to this 2D array right here, because if you think about it, an array is basically a one-dimensional rectangle. So it still has that dimension of 1, like in height, and then the I would be the length of it. So to access that each index of the string, you have to use the second bracket right here. So now to break, like we said earlier, to end the loop, I'm just gonna set I equal to len. That'll break us out of the loop, or I guess I could break or something. This is how I did it. So now we're gonna get out of the for loop. Yeah. And we're gonna do another if statement to check, to move on if the key is valid. So if the key is valid, we're going to ask them for the plain text. And we're going to store this in a string called plain. The string plain get string. That's what I used. You can name it whatever you want. But this is mandatory. You have to type it like this for CS50. And then after that, you're going to take the length of the plain text. And this stores it in an integer so we can use later. I think at this point I didn't even know what I was going to do with it. I just saved it just because I knew that was a number that I might use later, which we definitely will. So here we're going to open up a for loop to start going through the letters of the plain text. So we're going to start getting used to these for loops. It's the structure of it. Setting an integer, declaring an integer I, setting it equal to 0, and we're just going to go through the entire length of the plain text by using that variable we created. Alright, the fun part is here. So, like I said in the pseudocode, we're going to need to, actually we have to add to it. We're going to have to handle. Let's do 8a, so I don't have to renumber them. Handle, upper, and lowercase. So let's plan for that now. So we're gonna check, like going from the bigger problems down to the smaller. We're gonna check to see if it's uppercase or lowercase. And the way we do this is we're gonna use a function from C type. So if is upper plain index of I, so we're starting at 0 here, so plain, so the first letter of plain, if it's uppercase, it's going to return either true or false, and if it's true, it'll go into here. From here we can set up the stage for the lower one too. So if is lower of plain of I, well, let's do the else if. If that's true, then it'll go through that, go to this body right here. Alright, so after we've done that, we're going to do some ASCII math. So the way ASCII math works is you can do like z minus, well, you have to use quotes. So like z minus a, and that'll return you a number. And you can just look up on ASCII table, like just Google ASCII table, and you'll find all the values. I think A is like 97 or 96. But we can let the computer do the math for us, like David Malin said. So here we can do, what I did was I used plain I, added it to the key that we were given, and I check if it's greater than Z, capital Z. So in this situation, if that letter is plus the key is larger than capital Z, that means we have to do some wrapping around. We can't just tack on the key and expect the computer to just know, oh, like let's say we add 20 to Y. that's going to bring it to the lowercase letters or like symbols or whatever, you know what I mean? So we have to make it wrap around the alphabet. And so to do that, we're going to have to get like a key remainder of some sort, some way to track the number that wraps around. What I did was I stored a key remainder as an integer using this little formula right here. So what this does is it just adds the key to the letter's ASCII value, and then we subtract z from that. So that'll take away one alphabet's worth, and then give us the number that went past the z. So now we check to see if that key remainder is greater than the entire length of the alphabet still. That's a pretty big number. So if it's still bigger than the alphabet, we're gonna have to use some kind of like modular math, but I just used a big while loop. So while the key remainder is still larger than the entire length of the alphabet, it's going to just subtract the entire alphabet from that number until it can fit inside the entire alphabet. So once it can fit inside we don't need to worry about the wrapping anymore. We check if the plain text is the letter that we're focusing on, plus the key remainder is still greater than z. Because like I said, it could be y and we're adding 20, because 20 is still less than the entire alphabet length. So we'll take the key remainder and make it equal to plain text, the plain letter, plus our key remainder, but we'll subtract z from it one last time. And we'll just tap that onto A. Alright, we definitely have to remember to subtract 1, because if we add on to A, then we're not really counting A. It's kind of like starting at 0. So if we subtract 1, then we include A in the equation. Okay, so else. Now we're going to handle the case of if the key remainder was already a manageable number. Because as we saw above, we didn't have a manageable number and we had to make it manageable. So we can just go ahead and add it to A. To shift it to its encrypted form. Again, we'll need the 1 because we need to start from A. So we're going to do else plain I is equal to A plus key remainder minus 1. So this will just add the key remainder to A. It needs to be capital A. Alright, so now I'm going to move on to a situation where our letter from the plain array plus key remainder, wait, let's do iron, was never greater than z in the first place. So now we can just tack on the key remainder like above. But but in this one we don't have to go through the loop of whittling down the key remainder until it's less than the distance from A to Z. Okay. And then yet another scenario here we set up an else if for the simplest case. The letter we're focused on can simply be added to the given key to give us our encrypted letter. I think I got that right. I'm pretty anal about my indentation, as you can see. Okay. So here, we'll just do the same thing. Yeah, so I thought it would be cool to show you guys a very bad implementation of this. Just because, I mean, I'm not embarrassed of my code, you know, but it's also good to see for beginners, I think. Because we can't all see in terms of like zeros and ones, basically. So here, the simplest case is handled, and we can move on to the lower case, which the lower case is very much the same thing. I can just copy and paste the whole thing up from here to here. Paste it here. This mouse is so garbage. Okay, so we'll just start replacing the uppercase letters with lowercase. So now it's going to be difficult to get to this part here. I'm going to have else right here, because now we're done with the lowercase as well. And this else statement is going to catch anything else that goes wrong. Honestly, I just put this in because the IDE was throwing me errors. I mean, the check50 was giving me an error saying that there was some case maybe that it didn't return this, but it passed the check50, so it wouldn't really tell me, you know what I mean? Let's erase that for now. God, this mouse is so fucking frustrating. So after this for loop, so at the end of this, the is key valid for loop, we're going to print f the ciphertext. We're going to print it just like check50 wants us to. Then underneath that, we're going to do an else statement for any other cases that I did not foresee to print out the error again. Alright, so let's copy this, paste it, and we're going to run check. First we're going to make it. Okay, I have an error on line 44. Okay, I've been doing Python, so on line 18, line 14, we have to add a semicolon. Here. Line 84, 122, 131. '84, 132, 122, 131. Okay. Let's try making again. Alright, we compiled. Let's cross our fingers. Let's try this one. Hi. Alright, we got JK. So let's see the check50 to see if it works. Okay, so I'm going to show you guys the error I made and why that bar food thing didn't work. So we're going to have to go to my while loops, where I was subtracting the length of the alphabet. And apparently z minus a isn't 26. So that's where we went wrong. We get 26 here. And let's see if it runs. Makes Caesar, compiles. Then we're going to check 50 yet again. Alright, there we go. I'm going to include a copy of my code from the GitHub in my description below, so check it out if you need to follow along. And good luck. Thanks for watching through or skipping to this point in the video. If you like my content, like or subscribe, and I would appreciate it very much. Thanks.